Friends, today we will start the PowerPoint presentation on logic gates. So, basically the logic gates is used in computer systems. So, here, in logic gates, we will see different types of gates like AND gates, OR gates, NAND gates, NOR gates, and inverter gates. So, in the particular presentation, we will see the course objective, then different example of gates. Then afterwards, we will see the truth table, symbol, timing diagram, and the equation of OR gate, AND gate, NAND gate, NOR gate, and NOT gates. So, in learning outcomes, so after completion of our logic gates topics, students are able to identify the logic gates that will be used for as the switches that turns on or off depending on what the user are doing. So the logic gates will depends on the, or it will works on the two logic. One is on logic and another is off logic. The on logic will be called as a 1 bits and off logic will be treated as a 0 bits. Then in second outcome explain the building blocks for how computer works. Then draw the symbol of different logic gates and identify the different operation of logic gates in real lives. So what is a logic gates? Logic gates is basically work as a switch. The logic gate turns on when a certain condition is true and off when the certain condition is false. They check whether or not the information they get follow a certain rules. They either split the answer into two options, that is true and false, that on and off. So here the student must remember that the true condition will be treated as on condition and that must be equal to 1, and the false condition will be treated as off condition that will be treated as a 0. So here we will start the reflection points. We'll start from the examples. So here I will take the two examples. So at the output that will be shown by violet color and the input will be shown by green and orange colors. So here if both the inputs are same, so here 5 and 5 both the inputs are equal, that will be applied to logic gates. Then it will be give the on logic. Then in second figures we will give the different input as a logic, that is for first input I will give 5 and for second input I will give the 6. So both the unequal input we will give to the logic gates, so it will give the off logics. So here if two inputs are same, then the logic gate will turn on, and if two inputs are different, it is unequal, then the logic gate will be turned off. Then again here we will give the simple examples, that is 1 1. In first figure we will give the 1 1 as the input, that is on condition, that will be applied to logic gates, we will get 1 as the outputs. Then in second figure we will give the different 1 and 0. 1 is for on, 0 is for off. We will give it to the logic gates, it will give the off conditions at the output of logic gates. So different types of logic gates. So here we will give the example of basic gates. We will not go for universal gates and all this one. So here the major gates are NOT gate, AND gate, OR gate, XOR gate, and XAND gate. So that is also, the equation is also called as a Boolean logic. In circuit schematic, each logic gate is represented by different picture like the one. So here in NOT gates, so NOT gate is also work as an inverter. So in figures we will give the one output, and for NOT gate we have single input and single outputs. So for this one we will give the input as a 1 and we will get the output as a 0. And for second gate will give the input as a 0, will get the output as a 1. So here the NOT gate will be work as a inverters. Okay. So second gate is the AND gate. So in AND gate, it is just like a multiplication. So here for AND gate we will give two inputs and one outputs. So the input condition is 1 1 if you are given in second figure, then the output will give only one out. So for 1 1 logic means both the inputs are 1, then the output will give 1. If unequal inputs or 0 inputs will be given, the output will be 0. So for in third figure we will give the input as a 1 0, output will be 0. Then again the input will be 0 0, output will be 0. Again 1 0 or 0 1 as an input, output will be 0. So in this truth table we will give input first and input second. So here 0 1 for a first condition of input, again here for 0 1 is second condition of input. So in this case the output, if 0 0 is the input, output is 0. If 0 1 is the input, output is 0. 0 1 0 is the input, output is 0. 1 1 will give the output as a 1. So similarly we will go for OR gates. OR gate is nothing but the addition of two input signals. So here we have two inputs and one outputs. So for OR gate, if you are giving 1 0 as the input, output will be 1. Then for third figure we will give 0 0 as input, output is 0. Again for fourth figure, if you have given 1 1 as input, output is 1. So for OR gate, only if both the condition are 0, output is 0, while all other condition the output will be 1. So in OR truth table, if you observe this truth table, if both the inputs are 0, output is 0, and while all other condition the output will be 1. So the reflection point is that the OR gate will be work as a additions of the two input signals. Then we will go for XOR, that is a combination of inverter gate plus OR gates. So XOR gate, here XOR gate is also called as exclusive OR gates. So for two input we will give the one outputs. So in this case, if both the inputs are same, output will be 0. If both the inputs are of different logic, means 1 0 or 0 1 will give, the output will give 1. If both the inputs are same, like 0 0 and 1 1, output will give 0. So this is the truth table for XOR gates. For 0 0 it will give 0, and for 1 1 it will give the output 0, while 0 1 and 1 0 it will give the output as a 1. So this is a logic gates diagram. So in this gate we have to use the inverter gate and the OR gates. So for upper side of figures, if you have given 1 1 as an input, so for this inverter 1 2 0, so input for first OR gate is 1 0, output is 1. Then 1 0 for second OR gate will give output as a 1. So 1 1 output will give 1. So here the simple example or the reflection point of inverter gate is that for single input 1 will give not, it will give 0 output. Then again 0 will be given it for second NOT gate, it will give 1 as outputs. So again example of NOT and AND gates, 1 will give for NOT gate will get 0 output, 1 0 and 0 will get the output. Similarly for this AND OR and XOR. So logic gates, the reflection point for the logic gate is that it will be used in a computer system for binary addition, subtraction, multiplication and division options. So this is the actual circuit for the actual pin diagram, or the what we'll say, it will actually look like a IC. So this diagram are easier to understand. Thank you and good learning.